So as we go into the second of these videos, it's the idea of adding displacement vectors. So you can go back to video 1.1a and look at what displacement is, but here we'll look at what happens when you add displacement vectors. So the first question is, all right, if you move 3 feet then 4 feet, how far have you moved? It's pretty simple. You've gone 7 feet because I haven't really asked you about how far away you've traveled from any given spot. It's just how far have you moved. And if you've gone 3 feet, then 4 feet, you've gone 7 feet. But what if I were to ask you instead, how far are you away from where you started if you move 3 feet, then 4 feet? That's one of those obnoxious trick type questions because there isn't just one answer. It really depends on how you move, how you traveled those 3 feet, then 4 feet. Because really you could be anywhere between 1 and 7 feet, literally anywhere between 1 and 7 feet, depending on how you completed those two movements. So you have to be careful being specific about things when you're asking a question, especially in physics. Now let's say you're moving in 2 dimensions. So we are generally thinking about 3-dimensional motion, but most of the time when we're moving around in the world, we're just going on the horizontal plane of the floor, whatever that is. Occasionally we worry about moving up and down stairs, up and down ramps, things like that. But in general, we're only worried about 2 dimensions at a time for the most part. So when we have that change in position, it's called displacement. And we're going to use displacement delta R, which is a piece in the horizontal direction, a piece in the vertical direction, or north, south, east, west, whichever 2 dimensions we're talking about. And when we're calculating it, it's by looking at the difference between final minus initial for both the horizontal and the vertical, or the east-west and the north-south, however we define those axes. So for example, let's say you're driving in a city, you can only go one way at a time, and so you don't necessarily know what direction you're needing to get to a specific location. Your Google Maps is leading you astray, and you think you know where you're going, so you're not paying close enough attention. So you follow the path below. You go 4 blocks north, 2 blocks west, 2.5 blocks north, and then 4 blocks east. So you've made all of these individual displacements. So if we want to figure out your overall displacement, we have to look at how those combine. So the north and south will, just because as we draw it, it usually is in the vertical direction, so we'll use that as y, and then east-west will be our x direction. So all the 4 displacements to kind of move together. So horizontally, we had 2 motions, 2 east-west motions, and we had 2 north-south motions. So in the horizontal, we went 2 blocks west and 4 blocks east. That combines to be 2 blocks east. And then north-south, we did 4 blocks north and 2.5 blocks north. So that's 6.5 blocks north. So to really represent this, we're not just going to draw it as 2 separate things. We can actually combine those together in a triangle. And the nice thing with north-south and east-west being perpendicular to one another, it'll be a right triangle. So here's our displacement. But we have to find the magnitude and the direction of the displacement. This gives us most of the information, but that doesn't tell us how far the displacement has actually been. So to find that, because we can draw this as a right triangle, to find the hypotenuse, our overall displacement, we just look at the horizontal components, the vertical components, so it's just Pythagorean theorem. And then by using the definition of tangent of the angle theta is the opposite over the adjacent, then we can rearrange that with the inverse tangent to get the angle. So our solution, our overall displacement is 2 blocks squared plus 6.5 blocks squared square rooted. That's 6.8 blocks. And that our angle of 72 degrees rotated toward the north from the east. Let's say instead of having a displacement, purely north-south or east-west, what if it was at an angle originally? So what we have to do is we can actually work backwards from there And with the displacement, we can find what are called the components, which we'll talk about a little bit more in class. So if we know the displacement, we can find the delta x and delta y. So just by using some of the definitions that you get from trigonometry. So the sine of an angle is the opposite over the hypotenuse. So the opposite in this case from the angle is our y component, and then the hypotenuse is delta r. And the same thing for cosine of the angle. It's the adjacent over the hypotenuse. And then with those things together, we can now solve for the individual components. So the horizontal component is just going to be the overall displacement times the cosine of the angle, and the vertical is going to be the overall displacement times the sine of the angle. So when you have the x and y components, you can add them the same way as you did with the perpendicular components, and we'll do more of that in class. So anytime you have displacements, you can break them into their components and then add the components. So anytime you have multiple components, you can just add them up and then create a new right triangle to solve, which we'll show in one of the next videos.